Hey guys, please note that this session is being recorded. You will have a recording. At the end of the session, I will create an MP4 file or some other video file, and I will put that in the sync software. It will automatically synchronize to your laptops and desktops so that you have a copy and so that you can review this. So we are talking about software. The companies such as Microsoft will prepare this tool called Microsoft Word, and this is Word for Mac. But today, Microsoft doesn't sell you a shrink wrap box product called Word or Excel or PowerPoint. Let's go look at what Microsoft actually sells today. In Office Depot, can you find Office here? So there is a complaint about audio not being clean. I'm going to switch my microphone. I think that will help. So
Can you hear us?
I'm going to switch my
Hello?
microphone. That must be the problem. So hold on. I'm going to switch my microphone. Can you still hear me okay?
So there is a
Nilesh, can you hear
connection
us?
lag too. There is a connection lag too, Nilesh.
Nilesh, can you hear us?
Yes, I can hear you. Now, is the audio any different or
Okay.
better?
It's pretty bad. You sound like you're in a tunnel or a well.
It's sporadic, Nilesh. It's cutting off at times. We're losing parts of your speech. Just want to make sure that
it's not that the audio quality is bad when we can hear you, but it just goes dead quiet for 10 seconds or so, and then you come back. So it's intermittent. Maybe every 3 or 4 minutes we lose 10 seconds.
But when you don't use your microphone, the sound is not good.
So it is the intermittence of the sound which I have to understand what may be causing it. If it happens again, I will have to figure out another way to solve this, and I will do that. In the meanwhile, if you think that there is still a data loss, I will switch my audio channel to a phone line. I'm currently using voice over IP. If that persists, if it happens like 2 more times, I will switch over to a phone system and I will just dial into this GoToMeeting so that you have audio separate from computer. I hope it doesn't cause any problem, but that's the plan of action. As a fallback, I will switch to a dial-in system and we'll use the telephone system for connection. Right?
Right.
that sounds like
good.
a plan.
Okay. So AV is also concurring with that same idea. Alex saying the same thing. You may have to dial in, which I will, but I will dial in using a phone line. So if you look at the product set that Microsoft sells here, let's see Word. If you can find, there is this Office product available, and it is available in form of a subscription. See that Office 365 subscription is available. Think about any major company that makes software today, Adobe.com. Adobe used to sell a $3,000 product called the Master Collection. But today, Adobe sells you a subscription. The subscription is called Creative Cloud. It is $9.99. The trend essentially is that most companies have evolved from selling a product, not anymore, into a service. What does that basically mean? Is that you don't have to like sell $3,000 of master collection from Adobe, but instead you convert yourself into a product that becomes a subscription on a monthly basis. It's per month pricing as opposed to a one-time pricing. That pricing model change is what is driving the industry. You can see this in strangest of places, like really, really strange. I'll give you an example of a razor company that is shifting the model of pricing from your Dollar Shave Club. Look at this. It's the Dollar Shave Club, and what they're doing is that they don't charge you for a razor, but instead they are charging you on a monthly basis. They have a program that you buy these blades, and you can then sign up for a $1 a month small blade, $6 a month medium sized blade, and $9 a month a bigger blade. And you you pay them a subscription, and they'll give you these blades as a service. And so they have fancy way of delivering. They're competing with Gillette and major blade companies. The idea is to convert into a service. That is what is happening. In technology terms, this thing is called SaaSification. People are converting their software into a service and are converting that and basically SaaSifying their products. That is what is happening in the industry across the board. Every single company that I see that is worth talking about is doing it. Every domain, every industry, including airline industry, is also doing it. I'm suspecting that you have applications that you will provide in Boeing. You will have applications that you will provide to companies such as Emirates that they can then order parts from you or things of that nature. So underlying that is the trend in the industry, and what is essentially driving these things are things such as what we generally call cloud computing, right? The word cloud computing. The word comes along and people discuss, and everybody and their brother and their sister have their own interpretation, their own definition about what cloud computing is. But in the US, we do not believe anybody except the national standards body on what that definition is. And so we go and rely on this institution called the NIST. And this institution is responsible for defining the standards in our country. Now, having said that, the standards set by this institution tend to get also followed by other countries, even outside the US. And what they have done is set out a definition, a formal definition of cloud computing for us. And let us go read that. So here is a good bedtime reading. It is 8-page long, and these two guys together have constructed a definition of what cloud computing is. So let us go read that definition. It's the formal definition of cloud computing. Now, I don't intend to read the whole thing right now, but I'll give you some very subtle highlights, some key characteristics that are important for us to understand. What does the NIST mean by cloud computing? Everybody can have their own definition, but we will follow this definition to understand what the US standards body agrees as to what cloud computing is. So I'm going to paste a link to this document. You can read it in bedtime if you feel like sleepy. That's a good one to read. Now, having said that, don't have to read it right away. I'm going to highlight some of the key aspects for you right now. Let's go focus on some of the key characteristics. There are 5 essential characteristics. They are defined here. The definition itself is very small. It's actually from here all the way to this one. So 3 lines of English language constitute the definition. Let us read that, only these 3 lines. It is a model to enable ubiquitous, convenient, on-demand network access to a shared pool of something. Now, what does that mean? There is something to be shared. It is available on demand, convenient, and available on the network. So basically, we are talking about sharing something, and that the thing that we want to share essentially is a set of resources. What does that mean? What resources we are talking about? There are 3 types. CPU, primarily, storage, and network. These 3 resources, we are collectively putting them in a place and then sharing it with other people over a network. And people can conveniently access it on demand whenever they feel like. And it is ubiquitous, meaning they can go wherever they are in any country, any location. They can continue to access these resources. So this is the shared resource. We call it the R resource. It includes CPU, for example, or networking capabilities, or storage capabilities. So that's a general purpose resource that I want to share. And if you go back to the definition, it says Ubiquitous, meaning you can connect it from anywhere you feel like. Convenient, it is available on your mobile device, your laptop. On demand, whenever you feel like. You get up in the morning, 2 o'clock in the night, you have access to the machine, to the resources you want, you can connect to it. And it is a pool, and it is shared, meaning other people can also access the same resource. It is configurable, meaning you can adjust, you can make it big, you can make it small, you can adjust the size. What does that really boil down to? Is that you get access to high-end hardware in the industry, in the compute industry, meaning you get access to CPU, storage, and network resources without having to spend a whole boatload of money upfront. That's what it really boils down to. So if you imagine you want to set up a large data center with tons of CPUs and storage and network connectivity and all that, you will spend a lot of money upfront. But the idea is to not spend money upfront. How do you pull that off? You basically rent the resource. The key word here is to not buy, but rent. And so imagine if you want to set up a large data center. You will have to buy the equipment, the land, the property, the cooling, the electricity, and hardware, software, and all of the tool set. That will cost you like maybe $10 million, just an example. Whereas on the other hand, if you decide to rent the same thing, instead of spending $10 million, you can get away by spending maybe like $2 an hour. And that is a fundamental shift. Imagine this. You have this expensive car, and you try to buy that car here. And you buy it, order it, and the price will be like $125,000. You keep adding, and the price goes up. So here the price is $105. Imagine the same car available for rent. So as opposed to $105K upfront, you can probably rent the car for say $300 on a day basis. That's a very affordable model of usage compared to putting up $105 grand upfront. And that usage model is what is at the foundation, the economic foundation of cloud computing. Essentially, you don't buy, but rent. That is what this definition entails, essentially. That they're hinting at that very, very, very subtly. They're saying on demand, you get that idea. Whenever you feel like, broad network access. You have access to computers through mobile devices, laptops, desktops. You can connect to the resources you want to access. You don't have to be there personally. You can just remotely connect. How does that actually work in real life? Let's say, for example, I have this terminal, which is a tool that you have in your workstation also, by the way. And through this tool set, if I want to connect to the Cloud Genius website that is running in some cloud somewhere, I will use a tool and then connect to let's see if I can connect to the machine out there, the actual machine that is running out in the cloud. Let's see if we can go there, Vagrant at aws.cloudgenie.us. Let's see if it allows you. Okay, for some reason that machine is not accessible to me right now, but the idea was to be able to hook up to any computer that you feel like using a tool set. The tool that we were attempting to use to connect to a rented computer was SSH. This tool is called Secure Shell. It is extremely popular tool to use to connect to any computer away from us. The idea is to be able to use the rented machines and use this tool from your desktop, from your laptop, from your mobile devices, and connect to them. What does that basically mean? Is that you have some cloud somewhere. Let me be specific, and I'll actually go to that example where I have this Cloud Genius work actual site. This site here, the one that you are looking at, this site is running in the Amazon cloud right now, and I need to log in. And that is what I'm doing right now to show you where that machine is, and just to illustrate the point. You will see that in the Amazon cloud, I have in the Oregon region here, this one running instance, this one. And that running instance is running Docker, and it is at this IP address. And that is the IP address corresponding to the Docker container that I have running, which is actually running this site. The idea, the reason I brought this up is that you are able to create some resource somewhere in some cloud, like this one, and then sit in your office and use a tool such as SSH to connect to that resource and make use of it. Anytime you feel like you want to grow the machine, make it bigger, you make it a big R like this. You want to make it smaller, you can make it a small R like this. You can grow and shrink. Small R, medium size R, big R, and the resource can grow and shrink as and when you feel like. And you're still in your office. You don't need to go to the cloud. You just connect to it and make use of the resource. That's what essentially is what is illustrated in this definition, is that you can access the machines out there on a network and keep using it. Resources are pooled, they're shared, meaning the same machine that I have here in my Amazon account, you might have your own resource right next door to me, or other people who may be, I don't even know who they may be, will actually be having their own resources right next to me, and they may be using their own resources, and we all may be on the same physical box. It may be the same physical box that may be running our resources, 1, 2, and 3, and 3 different people. This is me, this is somebody else, and we may be sharing our resources. The idea is that it is a shared resource, meaning it is pooled. Other people may be using on the same box. There is isolation and complete isolation available, but you need to understand that it can be shared. Also, the idea of rapid elasticity, meaning you can grow and shrink the size of your resource. By the way, I should say that anytime you think that this is too trivial, or if it is too difficult or new, I need to know. If you think that this is trivial, I need to know that I should skip ahead. I will. By the way, I will speed up a little bit occasionally if I am not, if you give me feedback, that will be better. If you tell me that this is too trivial, I can speed up. But I just want to make sure that I cover core aspects of the definition itself, which are, trivial, but make sure that we understand. Rapid elasticity. The idea is to be able to grow these machines whenever you feel like. For example, let's say, today in the Cloud Genius site, we suddenly have 14 new people. Right now, there are 14 people signed on to this site. And so yesterday, they were like 0. Like nobody was there in the program. So now we have 14. So the load has increased from 0 to 14, right? Just today. Now, is my machine capable of handling that load? Absolutely, yes. No problem. 14 is too small a number. However, imagine when the number is not 14, but 14,000. Suddenly, I get a load of people showing up. Now what happens? The scenario essentially becomes that you have a case where you have this one machine. I'm going to draw this a little bit differently so you can get the picture. And give me a sec. I'm cleaning up parts of it here to illustrate the point. The point is that you currently have, say, for example, only one computer, this one, and it is in front of a user that is connected, and this user is connecting to that. Okay, let me get a pen, and so I'll let's see if I can. So the load balancer here, load balancer, and this is the machine that I'm running, and this is the database on the back end. You have only one user that is visiting the site, and suddenly these other people show up and they all hit the same site. In that case, I need to be able to, I think Michael is suggesting that we take a break at a given time. I think it's a great idea to take a break, and I must say that I tend to forget that there is a need, a biological need for a break for some reason. So if I forget, please remind me, and I think Michael, you did a great job. Please let me finish this idea and then we'll take a short break and we'll come back and continue. So the idea essentially is that when people show up on your site, you want to make sure that your equipment that you have, this machine that you have here, is able to grow in number. How do you make it grow? You can grow it in two types. One of them is to take this machine itself and make it grow like this. Make it a big fat machine. That's one way to approach. However, there is another way of approaching the same problem to make the machine perform better without actually growing like that. And that method is called, I'll come to the nomenclature later. But one way of growing was just to grow the size itself. The second way of growing was like this. You add more items, so add more instances. That's another way of growing the machines. And if you go that way, you can handle the workload another way. Basically, what you're doing essentially is that when you get more traffic, you add more machines. So you add more instances, more machines, like 1, 2, 3, 4, like that, and you keep adding. And that is another way to handle the load. And so there are these two modes of operation that I just discussed. One of them was that I make the machine itself bigger. And the other mode was that I add a lot of small machines, resources. When you scale like this kind of scaling has a word. There is a word for it. It is called scale up. And when you go back down and you basically shrink, this is called scale down. And this type of scaling, there is a different word for it. It is not up and down, but the names are out and in. Scale out and scale in. That's the word that is used, and we'll talk more about it. Let us take a short break. The idea is to be able to understand that these cloud resources are able to help the user base while keeping your costs down, while renting them, without spending a boatload of money up front in capital investment. And that's the overall idea of using cloud computing. Let us take a short break and come back here. So we have 7 o'clock right now. We'll meet here at 7:02 right now. We'll meet here at 7:07. All times are Pacific. 7:02 right now. Let us reconnect here. I am here. I'm not going anywhere. I'm here. We'll resume at 7:07. Thank you. I'm still here.
Hey, Nilesh, this is Rebecca.
Hi, Rebecca.
Hi, Nilesh.
Hi.
Hey, quick question for you. Not unrelated to the lecture. When I go to the Slack's application,
Uh-huh.
am I supposed to be able to see something under my channels besides general and public?
You should, yes, you should see a new channel, sorry, a new group that I have not invited you yet, but I will do
Okay.
that. So let me go find you,
Thank you.
and
I'm under it's RF Ander.
okay, I found you, RF Ander. I'm going to excuse me, I'm going to add you to the Badal group. Here we go. And excuse me, invite others to this channel. RF Ander. There we have invite. Excuse me.
Thank you. Perfect. Thanks a lot.
So thank you very much. Sorry for missing you. We have Alexander Ramos. Add you also as well. I will do that, Alexander. Give me a second.
Thank you.
Yeah, I can barely hear you now. Sorry.
No worries. I hope you can still hear me okay.
No, something happened. You moved your mic or something? I can.
Am I still muted?
No, you're not muted. It's just very, very, very faint. And you were okay just a minute ago.
Okay, let me see what went wrong. Okay.
Hey, Nilesh, I have a question whenever you are ready.
Yes, give me a second. I'll just finish up adding our buddy here, Alexander Ramos, and we'll then talk to you. Give me a second.
Okay, I'll take a break and come back then and we can.
Yeah, I think my audio should have improved by now. I hope. Is it better?
Your audio is much better.
Much better? Okay, good. So I was not paying attention to one thing that I fixed. So I think my audio should be okay now, bearable, I hope. So now let me add AR Ramos 84 to the to the group, and that is Badal group. I'm inviting you.
What are you doing? What are you doing?
I am adding Alexander Ramos.
Monster.
Hey, Helen, you're not muted.
Monster. Sorry.
No worries.
Talking to a bird. Sorry about that.
Unless you're a monster nut.
I know.
No, that's not you. That's a beloved little pet.
I know. I understand, but I'm just having fun. So
He is a monster. No, just kidding.
Yeah. So I think I have made sure that everybody gets added to the Badal group in group chat. I would like you guys to say hi. Hi, say hi in the group chat, please. And by the way, Deepak has a question. So Deepak, go ahead and ask your question away. Deepak? Yeah, Patrick says hi. Gautam says hi. So that chat that we are doing right now is a group chat. This is visible to everybody in the group. If you want to do a one-on-one chat, you need to find my name on the left side, and that is where you do a one-on-one. Without that one-on-one chat, it will become available to everybody in the group. Just so you know. So I'm just quickly checking who is missing in the AV. We have Alex Ramos, we have Cal. Yes, we have Deepak, we have Gautam, we have Helen. Hey, who's RF Ander? Is that Rebecca? I guess so. Yes. We don't see Helen in the group chat somehow. Hey, Helen, can you find yourself in a moment and add yourself?
Yeah, I'll get in there.
Okay.
Yep. Just give me a little bit of time here.
Then Conrad is not there in the group chat. Conrad, I suggest please visit this site called chat.cloudgenie.us, and that is where you can invite yourself to chat. So click here, and that link, and there you invite yourself so that you can come on group chat and then chat with everybody, chat one-on-one, whatever you feel like, and that is how you invite yourself.
Hey, Nilesh, real fast, whatever microphone you switch to, you have no more cutout problems. Your audio has been pretty steady.
That is good to hear. That was, yeah, I know it was my mistake. I was not paying attention to this stupid thing. I'll tell you what that stupid thing was, and then you will know what I was doing. So here it is. So what I was not doing is paying attention to the sound properties, and it was all pumped all the way down, which is silly. I'm supposed to be an audio video expert of all things. I'm not kidding. Some of
Well,
you,
you know, we're all human.
I know. I am definitely human, man. I'm definitely human.
Yeah.
I
know you're on the mend, so it's you're on the mend, so we'll give you a break.
Thank you. Yes, I was not paying attention to the volume level in the microphone here. Which should be the root of the problem. I hope it is fixed. So I was looking at Kiran Thomas. Kiran is on Slack chat. Kiran, are you there? Yes. Then Michael Curry. Yes. Patrick. Yes. Rebecca. Yes. Ted. Yes. Then Vamsi. Vamsi, where are you? Vamsi is also there. Okay. So I guess we are back, I hope. So we should resume. What we were doing essentially is this idea of understanding cloud as a resource and the essential characteristics. So the summary here is: on demand, we understand; broad network access; pooling as in shared resources; elasticity as in scaling. We just briefly touched upon it. The idea of scaling was something like new sheet of paper, add blank space. And the idea of scaling, there is two types of scaling. One is out versus in scaling, and the other one is up versus down scaling. Is that conceptually clear to you what I'm talking about when I say scale? I mean grow and shrink. And when I say out versus in, there is a distinctly different type of scaling involved here, right? Which is to be able to scale in a fashion that that grows horizontally and shrinks back horizontally as opposed to increasing the size. I'm just asking you a question. The question is, am I clear when I say that when I want to scale out, I actually add more machines on the pad here. So I'll add more machines like this. And this.
So is that more of a replication?
Yes, indeed. It is conceptually allowing more horsepower to serve a load that is being presented on by the users. As more users come along, you want to be able to service them. And that servicing will happen provided you have more machines to serve the need and be able to respond to the needs of these people, right? Imagine another example. The example I would like to give is the idea where you have the DMV. or the Department of Licensing, or RMV in Boston. When you get a license, you go to the office and you are standing in line, and there is this officer. The officer is going to serve you and give you the driver license. However, imagine there are lots of people here and they just lining up, like, only one officer here and lots of people waiting here and queues forming, and that's a problem. They'll all start complaining momentarily, right? Why the lines are so long, I cannot get my license in time. That's the classic problem. So how do you solve this problem? You can get the officers added up. So you can basically add more officers like this. And that way you can reduce the number of people waiting in line and expedite the process, give them their licenses quicker. And here, what you're doing is scaling out. You're not getting a fat officer, right? A fat officer like this. That doesn't help. This big fat officer is not going to be any faster. Equal size, people size officers will be able to serve the need of these people and give them driver licenses efficiently because you are able to scale out the work. This huge big size officer is not, there's no such thing, by the way. By the way, the concept is that you can scale up and down in physical computers. You cannot scale people like up and down. You can only scale out people, like here. You cannot grow the size of a person, but you can indeed grow the size of a machine if you need to. And in practice, when you grow the size of a machine, it becomes a bigger computer and it becomes an expensive computer. So it becomes more expensive. This is a cheaper machine. This is a more expensive machine, and you have to pay for it on an hourly basis, a bigger amount of money. And so there are certain cases of applications where a bigger size box is more relevant, and there are certain other type of applications when smaller number of little boxes is more relevant. And so depending on the application type, you need to decide whether you want to scale out and in or scale up and down or do both. So it really boils down to how you mean by, what the application requirement is for scaling. And that is what elasticity means. Now, in the example where you have, let me say, this sheet of paper, when you have the case where you build a building and you spend $10 million and you have, visitors and customers, they will come. And you have so many people being served, say 100. And suddenly you get 100,000 more customers added on. Can your infrastructure handle it? That's the question to be asked. Now, if you are spending $10 million up front on a building and everything in a data center, it does not give you elasticity. You cannot overnight, or maybe in the matter of hours, scale and add one more data center. Can you do it in 1 hour? I don't think so. Nobody can. However, in the context of cloud, you can. What you can do is go to the cloud provider and say, I need more machines. Please give me some. And they will be able to quickly give you, in a matter of minutes, more computers. Just like copy and create and create and create and create. And they'll be able to do this very, very efficiently. And all you will spend will be something of the of the order of, let's say the pricing happens to be 0.02 per hour. And so you add it up, say you just increase the number of machine count from say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you have 13 times this number. And so you will be paying say 26 cents per hour if you just add up and from just one computer. If you increase to 13 different machines, your bill will rise from 2 cents to 26 cents per hour. However, if you're doing, go ahead, question.
Yeah, I was going to ask, would these be physical machines, or would these be VMs that were created in a physical machine?
So most cloud computers, most of them, as of today, give you virtual machines. A virtual machine is this one, is this one, and sometimes even this one. They're all virtual machines. In any cloud you can think of, most of the cloud today will give you virtual computers. So think of Amazon, Google, Microsoft Azure, everybody, they have their own technology to provide you virtual machines. So say, for example, Microsoft, they will use the Hyper-V technology to create virtual machines, and they will give you what is known as the Azure VM. In that VM, you can install Linux, you can install Windows, you can install whatever else you feel like, but it's just a machine. And it is using this technology to partition a big physical box into smaller parts. And you probably get this part. So in real life, any cloud provider, let's say Amazon, will take a big gigantic box, like 128 CPU and 64, maybe some obnoxious amount of RAM and hard disk and everything. And this is how the machine will look like. They will divide the machine into parts and create virtual machines. Now, in case of Amazon, they will use a technology called Zen, which is another hypervisor technology. And this technology will be used to partition the machines just like this and keep dividing and keep dividing and keep dividing until you get the size you want. And this is the size you may want, or you may want this size, or you may want this size, or sometimes you just want the whole thing. It's really up to you as to what you want, but most cloud companies tend to give a virtual machine. That is not necessarily true, by the way, because there are newer cloud companies that give you physical machines. And one such example is here. It gives you bare metal cloud, which means you click a button, you get a bare metal machine on demand, always. And the pricing is expensive because you are getting a real computer, full-fledged. And so it's like $1 an hour sometimes. And so this is storage heavy, this is flexible, this is tiny but mighty and all that. But this is not real, by the way. This is not it's an Atom CPU. So it's very, very cheapo, slow CPU. Practically, you will get one of these guys. So it's $1 per hour. It's expensive, as opposed to cents per hour, like I was saying before, 2 cents, 30 cents. The pricing is ridiculously cheap. Let's go look at some of the sample pricing so you'll get an idea about what pricing I'm talking about. Amazon EC2 pricing. And let's look at some pricing examples. The pricing is, say, here. What are we talking about? We're talking about 0065 per hour. It's ridiculously low. I cannot believe that low. It's the smallest size machine you can get. and it barely works, but it works. And the price is less than 1 cent per hour. And it has like a half a gig of RAM, 1 CPU, and things like that. So T2 Nano, T2 Micro, so variety of different sizes. And this is what I mean by scaling up. When I am taking that machine out there that I was drawing you for a picture, and I take a computer here, let's say this one, and I want to make it big, I'm basically changing the machine type from T2 Nano to T2 Micro to small to medium to large to extra large to 2 extra large to 10 extra large to goes on and on. There are lots of different sizes, and we'll understand this eventually. But for right now, the idea is to be able to grow like this. That is what is scaling up. And you scale down like this. And on the other end, you scale out and in. And so there are two different models of scaling, just so you understand this. You can have big machines and then scale the big machines also. That is also a possibility. You can mix and match, but just understand these concepts. Back to our definition, finishing that one off. So we understood these things. The last one is measured service, meaning what does that mean? Anytime you're using a machine, you are going to get a bill. And a bill is something that you have to pay. Because if you don't pay, they will stop your machines and cut you off. It basically boils down to you putting a credit card or your company putting a credit card there with a cloud provider. And so that's what measured service means. It will get you a bill. It will grow and shrink. It is shared. It is available on the network. And it is available anytime you feel like. So these are the 5 key characteristics. Any questions on the concept of characteristics of a cloud as defined by this paper? Go ahead. If you have a question, go ahead. You can ask the question anytime you feel like. Don't have to be right now. So I'll proceed. If it was too trivial, please tell me that it was trivial so I can speed up. Please do that.
Hey, Nilesh,
Yes.
quick question.
Yes.
So I understand it's an intro class, and maybe I'm jumping the gun here, but would you dive into more details? For example, like when you talked about load balancing, horizontal scaling, would you also kind of talk about what are the different types of load balancing?
Yes.
Like round robin or
Yes.
things like that.
We'll get to those examples in terms of scaling when you actually you will be able to implement these things yourself also. So now that you bring it up, let me just illustrate that point very, very simply. It's not rocket science, but it is as simple as the Department of Motor Vehicle and person 1, person 2, person 3, 3 people here. And officer 1, officer 2, officer 3, 3 people here. They are going to serve you on these tables, table 1, 2, and 3. And these people, as they walk in, the flow of how do you actually allocate a person P1, P2, and P3 to officer number O1, O2, and O3. There has to be an arbitrator. And this arbitrator is typically a cop. The cop regulates who goes where. As you walk in and you stand up in line at the DMV. Another scenario is US Customs and Immigration, right? As you come into the country, you have this cop that will arbitrate and dictate you to go, you man, you should go to that window. Great. So that's the allocation. This allocation is also known as load balancing. And so when you look at this picture here, and we are talking about these people who are coming and hitting our site, that thing here is the load balancer. that thing basically routes a traffic from these users over to any one of these computers that we might have. And since there are only so many people, it's a great idea to free up some resource and just get rid of the unnecessary things we don't need. And when this person comes along, the arbitrator here, this guy, says you should go to this one. And by the way, you should go to this one. And that allocation happens based on a policy that is dictated by this machine, and that is the load balancer. There are a couple of different methods of balancing the load. The most common method of balancing load is round robin. It basically means, you go here, then you go here, then you go here, then here and here, then one again, then two, then three, then four, then five, then one, then two, then three. So basically go in a loop. And 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, keep going round robin. That is most commonly deployed method of load balancing. Most people that I know of deploy it this way. It is also the default. If you don't select anything, this is how it gets deployed. There are some other variations to it, and that basically bring the aspect of giving a priority. So you have priority queues of people who need some help faster. So think about it this way. In another example, when you have Safeway and you go grocery shopping, you have these checkout counters, right? Checkout number 1, checkout number 2, and checkout number 3, and like that. But people with 10 items or less, they have a special checkout. And this one is typically different from most of the other checkouts. And people self-select, and they automatically select themselves based on this policy of 10 items or less. You go through this faster route, apparently faster route. Does not necessarily mean it is faster, but it's just a channel. And so people select themselves, and this is a slightly different method of balancing load. It is not round robin, but people typically will line up here and here and here. If they have less than 10 items, they will go faster by self-checkout and process through that direction. So that was a deviation of a standard round robin method of balancing a load. Now, having said this, we'll go over these details more with examples as we proceed. Patrick, you have a no message, which I did not understand. In the chat window, you have a no message. I believe that must be a typo. Let's keep going.
You were asking if
any questions? Okay.
It was too simple, and I said no.
Okay, great. No worries. Thank you for clarification. So the next idea that we have to cover is the characteristics we did cover. Let us understand the service models. There are 3 different service models defined. In the definition, we studied 5 characteristics. Now we'll cover 3 service models and then 4 deployment models. The core idea here essentially is service models. Essentially is what are you providing as a service? The simple thing is, what is the service that you're giving? Is it software? Is it hardware? Is it infrastructure? Is it something else? So now let us look at from a very, very different perspective as to what these things mean. And so anybody can tell you, software as a service, and platform as a service, and infrastructure as a service, and there is classic definition. You can read about it. That's not really interesting. I'll give you my perspective on what these things actually, where do these things come from, and why they are the way they are described. So let us look at how the money flows. Money flows in the economy. And so how the money flows kind of sort of dictates what these layers are. And let us look at that flow. And so I'm going to start illustrating a drawing, and I'll flip it, make it vertical up and down as opposed to left and right. So it's a new drawing coming up. And imagine you have companies in Taiwan that make hardware, right? They'll make hard disk, they'll make motherboards and things like that. So components, they make components. And companies will take these components and prepare computers. Companies such as such as Flextronics, or Compal, or Quanta, or sometimes HP and Dell and IBM and Lenovo. These guys will make computers. Or sometimes they'll create storage devices or networking units, such as Cisco company will come, a Brocade company will come and prepare computers or storage or networking. Those equipment will get created, right? These companies will prepare and create hardware, and this is what typically goes in a data center. And so these companies, such as, let's say, Lenovo as an example, they will give money down. Money goes down to the Taiwan hardware manufacturers, and components will go up. And these components will be used by Lenovo to construct a computer, for example. And let's keep building it up. Somebody will take these computers from the company such as Lenovo and put together a data center. That company will provide money down to the company such as Lenovo, who's making hardware, and the money is again flowing downwards. And components go upwards, then computers will go up to create a data center. And sometimes some companies will prepare themselves to become cloud providers, and then they will build their own data centers and create virtual machines based out of physical machines, and then divide them into smaller parts to create VMs, and then give these VMs to other people. And other people will then consume those VMs. And those people will pay the money to the cloud provider. And so at this level, you are basically getting access to infrastructure. That infrastructure is available to you in form of VMs. There are other types, by the way, but I'm just, at this moment, just giving you a VM example. So you are getting access to VMs, and you are going to pay somebody money. So now, from your perspective, if you need a VM, you get the VM, but you pay money down, and you give it to the cloud provider, who in turn will probably be paying somebody like a data center company, or maybe they will have their own data center. So the money keeps going down all the way to companies such as Lenovo. I'm just saying an example, and they'll get money. And the Lenovo company will then in turn pay companies such as Flextronics or Compal or Quanta, Quanta, Flextronics. So these companies will make computers for Lenovo. Lenovo puts the sticker, and these guys will get paid. These companies in turn will then pay component manufacturers, who will make components such as hard disk, RAM, things like that. So the money flows all the way from you down to the component makers, and it's a flow. At certain point, we have to define that this layer is what we will call a service, because you are getting a VM and you are going to pay them money. The definition that we have in the example, in the definition describes infrastructure as a service at this point, where you're basically accessing virtual machines, virtual infrastructure, and you're paying them money on an hourly basis. Sometimes some companies will charge you by the minute, such as Google does. They will charge you amount by the minute of usage. If you stop using within more than a minute, they'll not charge you for more than 2 minutes. So the layer or the distinction or this line that I draw essentially is a division between the people who are who are maintaining data center versus people like you who are using the machines. And there is a contract. There is a clear contract. You get VM and you pay money. That's a contract. Now, that is the contract that is conceptually, I would like to define it as infrastructure as a service, where you're getting some virtual hardware, virtual infrastructure, and you're paying them by the hour, by the minute sometimes, and you get to use this service. And that is how I tend to define IaaS. Now, not everybody would like to have a VM. Like, not every person on the street, as you go and meet them, they will not be using a VM. No. What do they use? They use Facebook, right? Twitter. They use applications. People, and I'm not calling you people, I'm calling you special. You can call whatever you feel like. But the idea is you are special. You understand these things such as machines and infrastructure and all that good stuff. But most people on the street don't. What do? They consume applications. They use Facebook. Just an example, right? Facebook is an example, very popular one. So Facebook is an application. That is what people use. And so this is what a person would use, right? Person. And they will pay you nothing. Actually, that's a different story. But Facebook becomes a bad example here. So let's erase that. I'm going to erase Facebook. And let's see a commercially available service of some sorts, such as TurboTax. Let's go, turbotax.com. turbotax.com. That's an app. It's available on the web browser. And people use it. They pay something like $65 or something for the tax season, and they use the application, and that person will be able to do his or her thing, file taxes. Great. That's what people do. Now, this TurboTax as an application is a classic example of what I call software as a service. This person has no idea whether they are using a VM or whether they are using a Windows or Linux, or whether they have a network bandwidth or any such thing. They have no idea. They don't need to care, and they don't even want to care. All they care about is, do I get my refund, or do I pay my taxes, or just make sure that it works. That's what they care about. And that is the line that I would like to draw when there is a concept called software as a service, where people don't want to get bothered about stuff. They just want to do their thing, and they just do it, and they move on. And so that distinction of a line, a contract, where they will pay $65 on a tax season and get through their taxes. That's the business contract. And that is an example of software as a service. Now, under the hood, let us now go deeper in terms of what is in between this SaaS business. And then we discussed infrastructure as a service business. So here I said, you will get VM and you will pay some money per hour. And whereas here I said, $65 for the tax season. And so this was an example of software as a service. This was an example of infrastructure as a service. You get a virtual machine and you pay some money. Where does this platform as a service come into play? What is that thing? And how do you define? And so to address that, there is a very, very simple concept that I would like to present to you. And it is trivially simple, so much so that you will actually laugh. In my definition of a platform is something that you put things on top of. So here is a platform and you put a thing. And so this is the platform. That is what my definition of a platform is. That's what most people, by the way, call it, a platform. You put a thing on something, that underlying thing becomes the platform. So is Windows a platform? Yes, you can put an application such as Word on top of Windows and then Windows becomes a platform. Now, bear in mind, I'm not talking about platform as a service. I'm just talking about platform. That's it. Nothing else. Nothing else right now. So anytime you put a thing on top of something else, the underlying thing becomes a platform. Now, who prepares these things, like such as this TurboTax? Let's go understand who's preparing TurboTax. So that's the question I have for you guys. Who makes it? This TurboTax.com. There is a company called Intuit. This company and the developers in that company make that software. And they need something to run their software. And they will put their software on top of something. And that thing will be a platform, which in turn will sit on top of some infrastructure, which in turn will sit on top of some cloud, on top of some physical data center, which will become created out of actual computers, which will be constructed out of components. So if you think about the overall game, we are talking about this guy paying $65 to Intuit, and then Intuit in turn paying their developers some money, some salary, and these guys will develop this software. They will put that software on some fictitious platform that we don't know what, but that is the platform that somebody called the platform developer at Intuit created. So somebody in Intuit goes and looks for some infrastructure and prepares a platform so that the software developer can then put that software on top of the Intuit platform to create what is known as TurboTax.com here. So you can see TurboTax.com, and then you sign in and all that good stuff, and you find out the online product, and then yeah, here $54 Premier, and then you use it. So you basically have a complete comprehensive software available on Access on your laptops, desktops, browsers, phones, whatever you have, and you're basically accessing the tax software created by Intuit, which in turn runs on some platform created by Intuit. This is the internal platform, internal to Intuit, which in turn they might have either taken machines in form of virtual machines from some cloud provider, or they might have their own internal deployment. We don't know. It could be internal cloud, it could be public cloud. We don't know that part exactly how they do it because it's their company, but they could use internal cloud or public cloud. I bet they use public cloud, but I don't know. And so this, in turn, that layer is the IaaS layer. This layer is the platform as a service layer that Intuit must have internal to their company, on top of which Intuit developers, these are software developers, by the way, software developers, and these are platform developers. They will develop the platform. They're typically IT employees who will put together a platform for the developers to actually run the applications. So imagine a case where a company has a internal internal cloud. So you have an internal hardware available to you that you can create virtual machines, and then you build your company's platform developers will build your company's internal platform and give it as a service to the software developer. So there are distinct roles here. There is a software developer role, there is a platform developer role, there is an infrastructure developer role, there is sometimes a data center developer role, there is a hardware developer role, sometimes these hardwares they call system developers, and sometimes you have component developers. So all these people basically are working to create things. Like component developers will create components, they'll give it to the system developers, they will put together systems that will get together to put in form of a data center, and that becomes partitioned in form of virtual resources, that becomes available in form of an infrastructure as a service, and that on top of which platform developers will prepare a platform custom required by the customer. And who's the customer for these guys? These guys. Because the money comes down and the service goes up. So anytime you're providing a service, you get paid, and the software developer is a customer for these guys. And these software developers in turn will create TurboTax.com, and they will provide that as a service to you or me. And then I will spend $55 for the tax season and use that service and be done with my taxes. So that's how you should think about these service classifications that are described here in the definition. It says software as a service, platform as a service, and infrastructure as a service. So that's what is basically, that's the concept that is being described here. And that what I just gave you is my perspective on how I like to think about these things. Any questions on this before we jump to the deployment models?
No, I'm good.
Good, great. Now, it's about deployment models, and there is a different way of thinking about these things. Let's go look at that. In the context of a data center that happens to be created in downtown Seattle, for example, and the company here called Amazon decides that they want to make this particular data center, convert that in form of a offering that people at large, public, can access and make use of a small little portion and pay Amazon 0.0065 per hour and get a T2.nano size machine. Okay, here it is. Go use it and pay me this much on an hourly basis. And when you don't want the machine, just delete it. And then I'll stop your bill and we are golden. So that's the concept, where anybody and their brother and their sister can access. That scenario is called public cloud. Anybody can come in. And that basically boils down to this problem that I would like to highlight, which is, let's say you have company A, and their competition is company B. And these are customers on Amazon Cloud. I'm just picking Amazon as an example. It doesn't matter, any cloud. But this is a public cloud. And so this guy A would have no idea that the machine that company B is setting up, the VM that company B is setting up, is on the same physical box that company A has. That may be the case. Who knows? The fact of the life is that in a public cloud setup, not just Amazon, but anybody and everybody who is setting up a public cloud will have a bunch of different geographic locations, such as, if you look at the map, I'm attempting to draw our world map, so pardon me, it'll be very bad drawing. But here is Seattle, here is New York, and here is Japan, and here is Australia, and here is India and Singapore, and here is China. And so you have a bunch of different locations. And so what companies will tend to do is most of these, and this is, by the way, Europe, they will pick up locations that are important from a geographic or strategic perspective and find cheap locations where they can build buildings. They typically tend to build buildings in cool areas where there is no need to cool down externally. The atmosphere itself is cool enough to cool down the machine, so they'll save some money. And they'll build up big, gigantic buildings, like multi-story buildings. And each of these stories, they will have various floors, and each of the floors will have multiple rooms, and each of the rooms will have gigantic computers sitting. And these machines essentially are the physical boxes. These boxes get divided into smaller parts. I'm not sure if each and every one of you has seen a cloud on a truck. Maybe, hold on. Crowd on. Let's see, cloud building block. Cannot find it quickly enough. So I'll send you a picture. The idea is to be able to identify a classic container, a container on a semi-truck. On the back of a semi-truck, there is a standardized unit of container, and that is how a typical cloud is set up. That you fit everything in that container-sized box, and you transport it to a location where you can just line up these containers on top of others and construct out your cloud setup. And these physical boxes will contain, there is a picture that Vamsi just sent us. So let us go look at that picture, see what Vamsi has. Click and click. So here's a picture of a container in which you will bring up the truck, and the back of the truck itself will be a ready-made cloud. You just put that in the building, you hook it up for cooling, hook it up for electricity, and that builds your cloud instance. And that is how you will put together and continue to build out your cloud. And so from a public usage perspective, you have no idea whether your competition is sitting on the same physical box or not. That's a risk. You need to understand that risk. And that's a risk in public cloud. On the other extreme, if you think that you are very vulnerable and that you want to protect yourself, and that your company policy doesn't allow things to be shared in a public cloud situation because you're not sure, in that scenario, there is a possibility of keeping everything inside your firewall. And in that setup, you can construct your own cloud, and that will be called a private cloud. So it's the other extreme. And in a private cloud, nobody else except you and anybody who's inside your firewall, only they can access resources here. Whereas in the public cloud, there is no concept of a limitation. So there is, by the way, firewall, but it is publicly accessible. So anybody who can put a credit card on the public cloud provider can get access to a resource in the public cloud. That includes your competition. Whereas in a private cloud setup, everything is inside your boundary. So people from outside cannot get in. They have no idea. They don't even know you exist. So they cannot even access. So that's how private cloud is distinguished from public cloud. Now there are certain cases, like example here is the idea of a hybrid cloud, which is a composite. You tend to mix and match. Sometimes companies will spend certain amount of money upfront and actually prepare a private cloud of a reasonable size that they know is going to be used all the time. For example, you have this chart that I'm going to draw, and this is January all the way through December. So you have January, February, March, April, keep going, and all the way through December. You know as a company that there is going to be a rough amount of workload year long. There will be some load on the machines all year long, and it will go up and down. And come September, October, you have this Thanksgiving, and day after there will be spikes because people tend to buy stuff and they visit your sites and all that. So there will be a spike here, and it will go on till Christmas time, and then some return period, and then it will die off and it will stabilize. So there is this pattern that some companies tend to know that there's going to be this bump, and that bump can be taken care of in a hybrid fashion. So think about it like this. When you know that you have a pattern, that you know that year long it is about this much of usage in the workload, but at certain times you need more, you need to take care of the bump. And so some companies apply this concept of a hybrid cloud. What they do is to take care of this amount of workload, this much, they will deploy a given size private cloud. And they'll be happy almost like 70% of the year. They'll be like just settled with what they have, private cloud works and all that good stuff. Now comes day after Thanksgiving, and they need to now suddenly scale out or up. What do you use? Depending on the application. In an e-commerce application, scaling out is more appropriate. So e-commerce, like say, for example, I'm selling some doodads, some widget somewhere on my website, or it is Amazon.com, the retail site, where people will start buying stuff as Christmas comes along, day after Thanksgiving comes along. So they need to pump and make sure that this is taken care of. Otherwise, the customers will go away, and we don't want that. So we want to allocate additional capacity as and when we need to, and then relinquish it when we don't need. And that scenario can be easily enabled. I should not say easily, but can be enabled by use of a mix and match strategy, which is called hybrid cloud. The scenario would be that year long, you will use private cloud. And come your day after Thanksgiving, you will supplement that with a public cloud. And when the Christmas time is over, you will get rid of it. And so this, the word some companies use or some people use is called bursting. bursting into public cloud. That's a scenario that some companies, some people tend to use, that you have a private cloud for a given size and you are comfortable in handling that. But as and when there is a demand that you need to suddenly provision for, you don't need to build up your own data center at the click of a button, because there is cloud. And so you can just put your credit card and pay them, I'm just exaggerating, but pay them 0.065 per hour and add 100 machines, or maybe pay them 0.02 and add 25 machines, depending on what the size is that you might need. But you can then grow your capacity to serve your customers, at the same time not break the bank. And that scenario is possible without having to spend money upfront. Sometimes you do, and that is valid. But when you don't know when do you need to spend, and it is kind of not predictable, or it sudden bursts come along and you need to spend money, you don't want to necessarily spend money on capital. Capital expense. The CFO will hate you if you ask them to spend capital expense. Instead, if you tell them, you know what, I'm going to spend a certain amount of money, such as 0.02 cents per hour for the next 3 months, they might agree. Because you know what, excuse me, they might agree because this is a very, very manageable amount of money, and you are seen as a person who is cautious and is able to understand that there is no need to spend capital expense, but spend only as you need to, depending on what the workload that you see from the customers. So that's the idea behind hybrid cloud. And before we take a short break, I'm just going to close out on this topic of the fourth one, which is a community cloud. And this definition, by the way, is basically when a given cloud is limited by use by a certain type of people, that becomes a community cloud. So you can read the definition here, but an example would be the government community. They have a cloud dedicated to them, and nobody else can use it unless you're a government employee. And they have a cloud called, I don't know what the name is, it's called GovCloud, sorry. So in Amazon, they have created a specific cloud called GovCloud, and we don't see it, but it is available to government employees, and only them, only they can use it. And that is an example of a community cloud. It is meant to be used by the Department of Defense, the Department of Energy, the Department of whatever, transportation, and they're all sharing it. But you and I cannot get it. I'm assuming none of you are government officers, which you're not. So the idea is community cloud is an extension definition, and it is defined by the community who's going to use it. And that's the concept of community cloud. Now, one last thing, hybrid cloud, the definition does not necessarily mean a mixture of public and private. It can also mean two different public companies. You can mix and match Amazon and Google Cloud. That also becomes hybrid. Now, this definition doesn't say that, but there are people in the industry that are using the word like this, just so you know. Now we can take a break. Michael Curry is suggesting. Thank you, Michael. It is 8:06 right now. Let us reconvene here at 8:11. And right now, yeah, go ahead.
Yeah, Neelish, there's actually one more type of cloud.
Yes, go
with
ahead.
Microsoft.
Please
and
go ahead.
It's yeah,
Go
this
ahead.
is Patrick.
Yeah, go ahead. Go ahead. Please describe.
Pardon?
Please describe.
Yeah.
Yeah.
It's one where Microsoft actually sets up hardware that is purchased by the customer. Microsoft manages it and allows that customer or company only access to it. So Microsoft operates the cloud for the company, and the company is the only one using that hardware.
Right. So I would tend to classify this kind of an arrangement as a private cloud because the ownership is with the company, the customer company. It may be managed by somebody else, like you say here in the definition. It may be owned and managed and operated by the organization themselves or a third party, such as Microsoft. It may
Okay.
exist on premises or off premises. So the definition actually includes that. But yes, you have a valid point. That's a model that companies don't want to again be in the business of doing grunt work. They just want to use TurboTax, so they just get along doing that. And sometimes companies also behave like people. They just want to get things done. And so they don't want to get into the mess of managing virtual machines or setting up patches and all that ugly things that people tend to do, or rather technical people tend to do. So businesses may not want that. In that case, they just stick to what they like most. In fact, that's the discussion we will have after the break. The discussion will be core competence. So that's what we'll be discussing after the break at 8. Right now it is 8:08. So add 5 minutes and let's convene. I'm still here.
Sounds good.
Yeah, I'm still here.
So, Nilesh, are you there?
Yes, hi.
Hi, it's Helen. So I've signed into Slack.
Yes.
Okay.
Let me check
Yeah.
and see. Helen. Okay, let's find out. Where are you, Helen? H. Coker. There we go.
Yep.
And so I'm going to invite you to the private group. And here we go. Helen invited. Click. And so you are now a member of the group.
Yep.
And you
Gotcha.
should be. So Vamsi has a question in the chat. He says, can it be hybrid cloud model as well? Because Microsoft holds it with the setup, but individual company can get the hardware of their choice. Yeah, the ownership essentially decides whether it's private or not. Ownership and access control. Who owns it and who can actually make use of it is, if it is only the company that is the private ownership, then that's the private cloud.
The question before which Patrick or some other person was asking on if it can be on the which cloud it comes in. So basically, like Microsoft was giving that offer. If the hardware is at the client side, like let's take some of the hardware can't be available in the Microsoft cloud. So when it is not there, then Microsoft can take this some agent running on the data center of what the client is having it, which the hardware is running, so that what exactly they want to accelerate on it and stuff, Microsoft can give it as a software service, and then the hardware is being still owned by the company.
Yeah, and in my experience, Microsoft actually specifies that hardware based on their best practices, and the company agrees to that, and then Microsoft manages it. So at least that's in my experience.
Is it still like the Microsoft have this opportunity, like if the client have a 2U server which he wants to use it with the NUMA concept of combining a 32 core and a 16 GB RAM together? So is it something happens like?
So the reason that companies tend to think, so there are companies such as Microsoft, for example, they will tend to operate in an environment that they know works well. Otherwise,
Exactly.
otherwise they will not venture. Microsoft will not touch something that is custom if they don't know what it is. If they're not sure what they're getting into, they will not touch it. So Microsoft
Yeah,
will
and
tend to prescribe, you know what, you want us to manage your hardware, then please get this this specific hardware. It has to be validated for hypervisor to run. Sometimes hypervisor may not run on other machines that are designed to run Linux or Zen or other open virtualization formats. Microsoft will, or just about any company, if you are getting into some long-term relationship with a business, you want to know what you're getting into and you want to control it. If not, go away from it, because you get in and you don't know what to do with it. It doesn't work. It brings you bad names.
yeah, the only time I've seen Microsoft actually allow, they manage all the hardware and they specify what the hardware is. What they will allow customers to do is actually create a colo with their own virtual machines. So that the customer, if they have a requirement for some specialized, let's say what do they call it? Two-part authentication. So they may have a machine or a server that is specific to that customer. They can actually create that server as a virtual machine in the Microsoft environment. But and that is the customer's machine, and it's in the colo, and that machine does what it needs to do, kind of sort of outside the Microsoft environment. That's the only thing I'm aware of. So.
So if we are back from break, we can start just checking. I think we are. So I guess I have the account. What is the password for the account? So are you talking about which account? The Cloud Genius site, Patrick?
Yeah, the Cloud Genius site. Yeah, because I've been trying to log in, and I assume it's just my name, but yeah.
Don't worry, I'll reset the password for you. I'll reset the password and then tell you what the password is. So no worries.
Okay.
So we are talking about this thing called core competency. Have you heard this word before? This word that I'm highlighting right now.
Yes.
You must have. It's a very popular word.
It's a buzzword.
Yes.
Yes, many, many thousands of times.
Exactly. So this guy called C.K. Prahalad, he is my professor in University of Michigan, and he coined that word back in, I don't know when, some like 40 years ago. He wrote a book, and in that book, he describes this idea of core competence of the corporation, and that's where the word was used first time. Now, why do I bring this word here? What is the relevance? By the way, he's this professor. He died about 5 years ago. He was my MBA professor at University of Michigan. He's famous, awesome, very well known, and of course, known for the word core competence. Now, the reason I bring up this word is a very, very simple concept. Let me illustrate that concept in simple terms, and by asking you a question. The question is like this, and it's going to be a trick question, so just listen very carefully. Assume that you are a brain surgeon. And it is Saturday. And you have a lawn that needs mowing. Okay? The question is, should you mow the lawn? What do you think?
No.
Okay.
If you know how to.
Yeah. Assume you know how. You know how. You know how to mow. And it is Saturday, and your lawn is grown up, and it needs to be cut. It needs mowing. Should you mow the lawn? That's the fundamental question behind core competence. Your core competence is brain surgery, right? You can fix people's brains and make them live. That's what you do. That's your core competence. Yes, you know how to mow, and yes, you have a mower and all that good stuff. Now, how do you go about answering this question whether you should mow the lawn or not? The simple way of thinking about if it is not Saturday, if it is Monday, the simple answer is no, you should not. Give it to the neighbor's son. Pay him $30, whatever, and just have him do it. You are too busy and too important to mow the lawn on a Monday because you should be operating on people's brains. That's a very simple logic. And that's how you should do, is what you really, really know how to do best. Is that's what you should do. And everything else, you should outsource. That's the concept of this core concept of core competence. You stick to your core competence. Boeing as a company knows how to make planes. Now, do they make automotive cars? I don't think so. Why do they not make automotive cars? Can they not make cars? They can. You know how to do it. You have a 5-mile long factory to make equipment and machinery. You can absolutely make cars, but do you make it? No. Why not? That is the question. The question essentially boils down to the fact that Boeing knows best how to make planes that fly consistently everywhere on the planet without a problem. And if there's a problem, they know how to fix it before it causes a disaster, right? That's the core competence that Boeing has. And so Boeing makes sure that it does not divert its attention towards silly things such as making cars. It might sound silly, but it is actually silly if Boeing makes cars, because that is not the core competence of Boeing. Sticking to core competence is what business is all about. Now, should Boeing be in the business of managing a data center? Should this brain surgeon be mowing the lawn on a Monday? Probably not. On a Saturday, I guess they might. They're doing nothing else, and there is nothing else to do, and he's like sitting idle, and it is nice and sunny outside. He hasn't exercised, so get up and mow the lawn. That's okay. I mean, that's totally fine because you have nothing else to do. There is no opportunity cost. Similarly,
unless you take the time to learn about brain surgery.
But he's an expert, right? He's a surgeon already established. So that is given, right? He is given. He or she is a brain surgeon. So that's a given. Yes, they know how to.
Yeah. What if you lose a finger in the mower?
Okay.
Seems like there's a risk there.
Yeah, there is a risk. There is always risk, right? There is always risk.
Yeah.
But there is this pleasure of mowing the lawn in the sun and a Saturday and leisurely doing your thing, at the same time getting your exercise and all that good stuff, right? So it's debatable whether you're on a Saturday, you have nothing else to do. Nothing else to do. Is it a good idea to mow the lawn? Maybe. If you have just feeling lazy, you can give $50 to a neighbor's son and they'll do it for you. That's totally okay. So it's debatable on Saturday, but it is absolutely no on a Monday. Now imagine Bill Gates walking, and on a Saturday again, nothing else. There's no business, no nothing. Uh, and he is walking on his own backyard, and he finds a penny, 1 cent, on the floor in his backyard. Now, should he bend down and pick it up? That's the question. Bill G, walking in his own backyard, finds a penny. Is it worth his effort to bend down to pick it up? That's the question. Now, how do you answer that? Is it his core competence to pick up a penny? Or is he too important to actually bend down? Or how do you answer? Oh, forget Bill G. Forget Bill G. It is me. Bill G is way too big. So, yes, me. I'm walking in my front yard and I see a penny. Should I bend down and pick it up? That's the question. Now, it depends on whether I'm actually going out to see you. If you are going to be there, I should not be wasting my time in bending down and picking up this penny because I am focused on meeting you in my front yard. So in that context, I should not be. But if I have nothing else to do and you are not going to be visiting, I'm just taking a stroll in the front yard and I see the penny, I think it is okay to bend down and pick it up. It is my penny and I have nothing else to do. And so it is the opportunity that I have to pick it up. And I should do that. And that is a logically correct answer, economically correct answer. Now, why do I say these things at all? Essentially, if you translate these concepts to managing data centers. To manage a data center requires a special skill. It requires you to know how to maintain machines, how to cool them down, how to keep connectivity, how to troubleshoot, and most importantly, how to do all of this at the lowest possible cost. If you can do these things and still manage a data center while keeping your cost low, then you know how to manage a data center. And Google knows, Amazon knows, Microsoft knows. These guys know how to manage data center. Facebook knows, FB. These guys know it. They know how to manage data center. That's what they do. I mean, that is their primary core competence. And therefore, they should be managing their own data centers. Not only their own data centers, but they should also manage my data center. In fact, that's what they do. I run my data center in a bunch of different places. And I rely on their expertise to run my data center. I have outsourced my work to them. And that is the fundamental premise behind cloud computing. What I'm doing is, instead of creating my own data center, I outsource it to Amazon or Google or some other provider. Outsource. And I outsource this to the people who know it best. It is those that have the core competence. Core competence of managing a data center. Give it to them. Do I have the capability to run a large data center and keep it cool and keep it connected, keep it up and running all the time, and make sure that I do not spend way too much money? Keep it the most cost-effective manner. I don't think so. I don't have that capability. And that is why I should outsource this activity to somebody who knows what they're doing. And that essentially is what cloud computing comes from, is people who know a certain thing will do that thing. If you are in the business of making widgets, then you should make them, you should sell them, and you should service them. But don't maintain your data center. Let somebody else do it. Let them do it. They know how to do it. Just pay them 0.0065 per hour and they will gladly do it for you. That's the concept behind focusing on your core competence. If your core competence is to make widgets, so you make them, you sell them, you provide service, keep your customers happy, and that is your core competence, so you stick to that. Not this. Let them do it.
That would also include companies like Adobe or Intuit as far as TurboTax and all that, because their core competence is tax software or Photoshop, not data centers.
Correct.
Right?
Correct. And in fact, that's what they actually do. In fact, if you look at Adobe or Intuit or any of these companies that provide you software as a service, they are very likely using these public cloud companies. We can find that out. Here's how you do it. Let's see how you do it. So I will go to the turbotax.com and ping it. And so I see this IP address, right? So I'm going to grab the IP address and see where the IP address actually belongs. It will give us some information about the IP address itself. So it is outsourced to Akamai. Akamai is a content delivery network. And what this basically boils down to is that turbotax.com, this site, is actually being front-ended. When you visit this site, you're actually hitting Akamai. And behind that, we don't know what they might have. There are tons and tons of layers there will be. But all we could see from a quick sniff was that TurboTax is pointing to some content delivery network called Akamai. And we'll talk more about content delivery networks and use content delivery networks momentarily. But what you just saw with a quick sniff was that they do not run their own CDN. They outsource it to these guys. And behind the scenes, there'll be a ton more things in layers and layers of services that will eventually build up to what you see to be turbotax.com. This is just a quick example. Let's do one more example. Ping adobe.com. I think adobe.com is maintained by themselves, but I'm not sure. Let's check. They maintain it themselves, I think. Yeah, it is maintained by San Jose, Adobe San Jose. So its ISP is themselves. So they are doing it, at least the front-facing site, adobe.com, is maintained by Adobe themselves. This one. And you can see that here. San Jose is where the office is for Adobe, and you saw that. So sometimes companies do it themselves. Sometimes they focus on what they do best, and then they leave the rest to other people who know best. Adobe is a technically sophisticated company, and they probably know how to do their own. So they must be using at least from their strategy perspective, have decided to run their own data center, which is nothing wrong with that approach. They just know what they're doing. Another interesting example is this Netflix that you probably already know. This thing where you pay $7.99 a month and watch all you can, like most of us do, except I don't. But that's a different story. Netflix as a company, you would think, would have a big, gigantic data center. But let me tell you, if you did not know, that they have absolutely no data center whatsoever. The entire Netflix company runs on top of Amazon Cloud. Even so much so that they have built their own custom platform as a service that is available only to Netflix. That this platform as a service internally runs on infrastructure as a service by Amazon. And that's where Netflix services run. And we'll have a case study in the third segment about this, in which we'll discuss Netflix in great detail and understand how that thing actually runs. And we'll talk more in greater depth in terms of what they do as an example.
Force.com does the same.
Yeah, Force.com is another interesting one. So Force.com is a platform. It is developed by a company called Salesforce.com. And Salesforce.com itself is a software. Salesforce.com is a software available as a service for salespeople. And what they do is allow you to maintain and manage your sales funnel or sales pipeline. And so this software, Salesforce.com, it used to have a logo which is kind of fancy. Let's see, Salesforce. The logo used to be no software. Look at this picture. It says no to software, but it is all software. And that is crazy. The reason they used to have this logo before was to indicate that the fact that you, dear customer, don't have to worry about software, because all you need to do is open up a browser, go to salesforce.com, and that's where you will have everything you need. So you don't have to set up any software. That's what this logo meant. However, they have recently changed the logo to this. And that's a change in their position. But the point being that Salesforce.com is a software as a service, which in turn runs on their own platform, which is available to public and also to Salesforce.com. So this platform is available. And by the way, all of this runs on Amazon Cloud. The underlying infrastructure that these guys use is Amazon's. So the concept that we are basically discussing back in our definition here is our deployment models can be private, public, hybrid, or mix, or community. The infrastructure as a service, as we understand, is basically getting hardware, virtual hardware. And I'll illustrate that virtual hardware. If you haven't seen a virtual machine before, which I'm doubting that, I think you already know. But just for the sake of covering it, I want to illustrate a couple of components to help you understand virtualization. The idea essentially is that this software you're looking at is a layer of software that provides me on this machine a method to create small little boxes in which I can put any operating system I feel like. How do I do that? Let us look at first my main machine. In my main computer, what do I have? I have a 4 gigahertz processor, Intel Core i7, 32 gigabytes of RAM, and a 4 gigabytes of video memory, and some physical RAM, 32 gigs, some storage, bunch of different hard disks, some displays. There are 2 displays connected. Actually, I have 3, but I don't know why the third one is not showing. And the idea is this is the physical box. Now, this box is what you're looking at right now. Now, I'm going to partition this physical box into smaller boxes. How do I do that? I'll take a picture of a piece of paper, and that big box that I have, I'm going to divide that into smaller pieces and use this size. So how do we do that? Let's do that. Let's divide a physical machine into. Michael Curry says, I think your specs are a bit weak. Yes, Michael. So a bit weak. Yes. Here. So on this machine, I'm going to create a new machine, a new virtual machine. So here, click new button. By the way, this is not what you will be doing for the Cloud Genius workstation. For the Cloud Genius workstation, it's very simple. You double click on the OVA file and you have it done. So this step that I'm doing is an academic step for you to understand how to do it nuts and bolts. Don't do it this way. For the Cloud Genius workstation, you do not have to do it this way. Do not. For Cloud Genius workstation, you double click on the OVA and that will automatically do everything for you, including seeing this machine right here, CG, that one. It will show up. But for the purpose of discussion regarding creating a separate container or a box where we can put our own operating system, that is what I'm illustrating. It has nothing to do with Cloud Genius workstation. I'm going to divide my physical box into smaller boxes by creating a new box. In this box, I'm going to name it. I'm going to say test. And I decide to put I can choose any operating system I have. I have Windows, and I decide to choose that I will run, say, XP, and I continue. Here, I can add some memory to it. I say I want to give 1024 RAM, and then create a hard disk of 10 GB. I can make it bigger if I like, but then I create a machine. And it is asking me what type of hard disk I want. And there are 6 different types of hard disk available. And these are VDI, VMDK, VHD, HDD, QED, QCOW. There are more varieties of hard disks, by the way. These are virtualization technologies for disk types. I'm just beginning with the default one and continue with VDI type. The next one is allocation of hard disk space. It is giving me 2 choices, a dynamically allocated size and a statically fixed allocated size, meaning all of the 10 gigabytes I can allocate right now by choosing fixed size. Alternatively, I can grow the disk usage as I need by selecting dynamically allocated, which is a much better choice. I don't need to spend all of my 10 gigabyte space right now because I can dynamically grow the machine as and when needed. And then I continue. And here I can even add more space if I want, make it maybe 120 gigabytes. You will notice a funny thing here, that my actual disk here is only 500 GB. But here in virtual disk, I can select 2 terabyte. Can you tell me why and how? My disk itself is like 500, But I can select 2048 GB, 2 terabyte. Can you tell me why is it allowing me to do that when I don't even have the disk?
Could you use network attached storage and mount it somehow on there?
You could, but I'm not using that either.
So it's as long it's not going to try to use it until you try to dynamically allocate it.
Bingo, exactly.
So
exactly, that's what's going on. It is dynamic allocation. So I can demand 2 terabytes. It might give me right now, but it will fail.
Yeah.
At some point.
When you try to actually write to those 2 terabytes.
That's right. It will fail because my disk itself is small. So that's the idea behind dynamic allocation of storage. Let's keep going. When I create the machine, I have a new box. Let's call it a box. It's called the test box. It will run XP. And here, when I power it on, it will expect XP compact disk image. But I don't have it connected yet, which means I need to go to the settings area and go to the storage section. And in the empty CD-ROM drive, provide it a disk that is going to be my XP CD from years and years ago. And so I will go look for it. I don't have it here for some reason, but I need to provide the ISO image in here in a virtual disk format, and that will allow me to start up an XP machine. Let me just finish that quickly so it illustrates a point and drives home a very good point. So I'm going to go see if I can find that XP ISO image somewhere on the network. And somewhere in here, in my junkyard, I will have that ISO. So this ISO, I'm going to copy and paste it here locally on my desktop. And then I can point this CD to the desktop ISO open. And now I have connected an XP CD. And now I can click OK and then start. And you will see that it is going to boot up XP first time. There it is, right there. You see that, right? That's the concept. I was able to partition a physical computer into smaller computer based on what I wanted. And I am setting up XP in there. And it will finish off very, very quickly if I want to, but besides the point. I don't want to set up XP for no reason. So I'm going to close this and say power off, and then right click and remove and delete all files, and it will completely eradicate any reference to the XP thing that I just discussed. So you can dynamically create machines and destroy them on your laptops, on larger machines if you have in a data center, or run the Cloud Genius workstation just like this, like I'm doing right now. It is basically carving out a space out of a physical machine and creating a small box running Ubuntu Linux, which is what Cloud Genius Workstation is. And that is what just started up. And this is the place where we'll be using this terminal, which you saw me use before to do a ping. You will also use the browser. And you will also use an editor, which is available here, this one, the Atom editor, which is a beautiful open source project. And that one is also installed here already for you. So we'll be using these tool sets as we proceed along. How many of you are using Linux first time? Just wanted to quickly check. Or rather, I should ask, how many of you have already used Linux at least once? Any show of
not professionally, only as a tool teaching.
Fair enough.
I've used.
Okay.
I've used. Most of the Boeing people have used Linux.
That's good. Good to know. So for those who are really new to Linux, I'll paste a link in Slack chat after the session, in which we will give you some starting steps for you to just familiarize yourself with Linux. especially the command line. This window, this command window can be daunting, but don't get scared. This terminal window can be daunting. Do not get scared. And most of the exercises, by the way, happen in the terminal. But don't worry, we'll cover. If you do not have experience with Linux, don't worry. We have a solution for that. Now, having said this, we have about 10-15 minutes left. I want to make sure that I understand from you how did we do, and a quick recap on what did we cover. That's what I want to do. So, first open-ended question: how do you think we did today?
I think we did well. I think we covered a lot of information.
Yeah, I thought this was a good overview.
Okay, was it too slow, too fast?
Well paced.
Okay, was it too trivial, too complex?
I think you
This is Cal. For me, it was about right.
Okay, good to know. Good to know. Anytime I keep that open-ended. Anytime you feel that it is too slow or too fast, you should tell me. Anytime you feel it is too trivial, too complex, you should tell me. Anytime if you do not hear me, I'm sorry for the initial trouble that we had. It was my mistake. I apologize. And if that happens, just like you told me, please tell me that this thing is not sounding proper, or I'm not able to hear you, or things like that. Now let us quickly recap. What did we do today? We did a couple of things. I'm going to recap right in the group chat, so you have there. First thing, we set up this chat software, right? That was one, chat. Second thing, we had this GoToMeeting going, and we have a standing link. The GoToMeeting link is https://gotomeet.me/cloudgenius, and you have it. The third thing we did was that you have an account on the CloudGenius site, which can be accessed at this location. I am typing in the Slack chat, and that is how you can access and access the material that is available to you for reference. Next thing, we also have a login which is different for chat. Some people have used their different emails in chat and different emails in CloudGenius login, and that is totally okay. If you want us to change these email addresses, I need to know. And so you just come on chat and tell me, and I'll fix it. Next thing, we have not created accounts yet. So we need to create accounts on a couple of cloud service providers. And before you jump on creating accounts with cloud services providers, I like you to point out that these cloud providers give us free accounts. So just want you to know that most companies will give us some freebie, and I want you to make use of that. And so on this site, there is a link in which I have accumulated all the free offers that people have given us. So on that link, if you go, you will find that Amazon gives you access to free usage for 1 full year for new users. So make use of that link and go through that to set up a new account. And yes, you will have to provide your credit card, but you know what, don't worry. They give you free access about 750 hours per month of a T2 micro instance, which is basically month long. And it is going to run for 1 full year. So it is going to be a year-long usage for you for one T2 micro instance, which is enough for us to experiment and practice. And even after the class, you can continue using it. So make use of this offer and open up an account. Similarly, Google Cloud and Joint Cloud and DigitalOcean Cloud and Azure Cloud, they all give you. By the way, we have a Microsoft employee here in the group. So I would like to request, Gautam, if you have a better deal than this, please give it to our class. Find internally if there is something better than what you have here on the public-facing site. If there is a special educational pricing you might have, please, please let the class use it. So go internally investigate see if there is an offer for education, and if you find something, post it on Slack chat so that people in the class can use of that, make use of Azure Cloud better than this $200 they're giving us. Is that possible, Gautam?
Sure. I can check, but I know even at the University of Washington, this is what they use. But I'll check again.
Thank you, Gautam. If there is something better than this, great. If not, of course, $200 doesn't hurt. It doesn't hurt at all. Yeah, so make use of these coupons that they have given us. They want us to use their cloud. That's why they're throwing money at us. Sorry?
No, nothing. Sorry.
Yeah, it's okay. So company, I've seen Google. If you go do a Google search, they'll probably throw you $1,000 of usage just to entice you to use their cloud. And so do those searches and sign up through them to create an account so that you don't get charged on your credit card for no reason. Some companies, such as Boeing, have internal access to a account. I think Conrad can tell you more about what you have, what you don't have. I don't know. But Conrad is accessible to Boeing employees, and he can tell you more about what he has. I don't know. He'll tell you. And Conrad is still online, or he's there. So ping him internally and figure out what you have for special for Boeing. So go check with him. I don't know what that special is. He'll tell you. But having said, the reason we use these accounts is that we can actually get some real life experience. So we'll experiment with a variety of different cloud providers while keep using open source tool sets to connect to these and understand what's the best out there in terms of a given scenario. And we'll do these things as we proceed along. Today, when we covered, we primarily focused on this discussion on the definition itself. We covered five characteristics, 3 service models, and 4 deployment models, and also discussed core competence. And then we summarized this. Now, having excuse me, I hope this cough goes away soon. Having said this, I would like to ask you if you have any questions or any other ideas that you may want to discuss before we close. And we meet again, I think, on the 21st, which is a Thursday at 6 o'clock Pacific time. That's the next session when we meet. In the interim, in between these sessions, I am always available. Repeat, always available in this chat. That's what I do. I am available to help you. So anytime you have a question, you can come here and chat with me one-on-one or group chat. This is our group chat.
Yeah,
Yes, go ahead.
Hi.
Yes.
Hi, this is Rebecca. I was just a quick question. I'm out on the Cloud Genius site under membership, and under free accounts, should all of the accounts be available, or because it looks like the only one that's not grayed out is Amazon, maybe, or
Let me see. So you have to click on the word.
Oh, I'm sorry. It looked grayed out, but it's just the way the interface is. Never mind.
You have to click through these tabs on the side, and then you will get access to it.
Okay.
Like you're looking at it right now.
I should have poked at it before I asked you. Sorry about that.
No problem. No problem. Anything is welcome. Anything is welcome.
So I have a question regarding scaling up and scaling out.
Mm-hmm.
What applications are best scaled up versus scaled out?
Okay. Yeah, very good question. I'll give you simple examples. In case of, say, high performance computing or something where number crunching is involved, you need a lot of CPU, right? So,
scaled up.
Yeah, in that case, you scale up. And when you're done, you scale down. Whereas if it is simple e-commerce transactions, and a large number of them, in that case, there is no point in growing the CPU size because these individual smaller size machines are completely capable of handling a transaction. You just need a lot of them. So you basically scale out. That's an example.
What about database?
Now, database is a different animal. Now, we are talking about, let me illustrate that point here. Now, databases are a different animal, and we are discussing right now at the moment where we are basically dealing with these transaction processing units, or the application servers or web servers as we can call it. Now this load balancer will balance the load load balancer will balance the load in between users and application or web servers. These web servers in turn will reach out on the back end to some database server. Now that database server itself becomes a point of contention if you have lots and lots of these machines and they all hit the same physical box containing your database. That becomes a problem. So how do you handle that? A simplest way to handle this is to let somebody who knows how to handle it. And that person is called, or entity is called, database as a service. They know how to handle it, so you just outsource it to them. That's a very simple way to deal with this problem. Now, who are these people that are database as a service? Let's figure out. Let's begin with looking at this example. What are they saying? They're saying we give you production-ready, cloud-hosted Rethink DB or Postgres DB or Redis DB or MySQL DB or this DB or that DB. That's what they do. Their core competence is to provide you database as a service. And that's what they do. So this is an example of an IBM company now. They got acquired. Compose.io is just one example of a company that gives you databases as a service. What that means is that they will give you an endpoint, where you don't have to worry about your database. You just connect to the service. And let them manage it. That's a very simple approach towards solving that problem. Now, this basically means if you give it out to them, you're paying them money. They will come to your cloud and set up a database service inside your cloud. They'll do that. But
so when you need more database capacity, do they actually scale it up or do they scale it out?
Out and up as needed. Do you decide what you want and they'll do it? You just have to add more money and they will scale. Okay. They will scale.
Okay, cool.
So this is just one example. There are other examples, and here they are.
Hey, Nilesh, I have a question.
Yes.
I think you kind of might have answered it by saying that the database as a service, would they typically go to your cloud and install? Because I had a question. I was wondering about latency issues where if you weren't running your applications on a platform that was near the database area. So,
Alexander, Alex, you have a very valid point. I want to illustrate that point and articulate a little bit more about latency issues. That's a very relevant question, by the way. Is this thing about, let's pick I'm pick some examples here, right? So I'm in Google Cloud. Let's say Google Cloud. And I'm in the central zone. And in the central zone, I have these boxes. 1, 2, 3, 4. Bad drawing. Okay. So 5 boxes. And I scale out and scale in and all that. And my customers visit. There is a load balancer here. Load balancer. And then I need to have my database service. As long as my service is right there when I have these machines all in the central zone in Google. By the way, Google doesn't tell you where central actually is. You just have to assume that it is somewhere in the center of the US. But they don't tell you where it is. So the assumption is that you will have your database boxes pretty close proximity to these boxes. And if that is the case, you are golden. If that is not the case, you have a bad problem. An example would be, let's say you have US East 1. This is Amazon, Virginia region. Now you have your boxes, 5 of them, in the Virginia region, but you decide that your database service is in Oregon. You will have a hard time getting your application to even work because of latency between these boxes and the Oregon location. So it's a stupid idea to put your database in Oregon while having your machines in Virginia. So don't do that. So these service providers, like I mentioned here, like this one, or there are more. Let us see if we can log in. So I'll show you what happens when you log in. I hope I can log in. Oh, there is a code question. Hold on, let me get the code. So I log in and I have an account. So I can set up any database I feel like here. So say, for example, I want Postgres. So I agree, I'll be paying them $17.50 for 2 nodes and 1 GB of data. And after that, it is just $12 per GB as your usage grows. It's that simple. So I select Postgres. And here it lets me choose that I want to go to Virginia or Ireland. Only 2 choices, by the way, in Amazon. Or if I am in IBM software, then I get US Dallas or EU London. Only 2 choices. And by the way, that's the entirety of choice. I don't have other choices. Which means if I have a machine setting up in Oregon region in Amazon, I am screwed. I cannot get this service. That's what it means. You get that point? Alex?
Sorry, I was muted. No, it makes perfect sense.
Cool.
So yeah, I guess you'd have to look. You wouldn't use Compose if you wanted to set up a Postgres database on the West Coast.
Bingo. Yeah, exactly.
So Nilesh, quick question. How do they commit on an SLA, like transactions per second or whatever, that they can process? But do they give an overall SLA or is it?
You ask them before you sign up. You open a ticket, ask them a question. What can you do for me? For $17, what will you do for me? And if you want higher SLA, you pay them more. They will do it. Just open your credit card. They'll do whatever you want.
No, my question is if they're offering database as a service and they're offering only 2 locations in this case, right?
Mm-hmm.
How do they come up with the SLA for the customer? Is there a SLA they give, or is it very specific to the customer based on how much money they're paying and where they're setting up their servers?
Right. I get that. So the question is, what is the SLA? For $17.50,
how many transactions per second can I process, right?
Yeah. So they will give you a baseline SLA, which will basically say that, you know what, you're on your own. And that's what you get. It's a very basic baseline SLA.
So how do I come up with the baseline SLA? Is it like the lowest value, like irrespective of, like you take the farthest place from their database data centers, and then you look at what the the processing time would be, or like
so
how
let
do they come up
me tell you the inside trick. The inside trick is to get away with the lowest SLA you can while not looking bad in light of the competition. That's the trick. It has nothing to do with what you want, because SLA is very hard to measure. And of course, when you go to measure, you have to pay more money, and then everything is all nice. But at the baseline SLA, it is the cheapest, the lousiest service you can get is what you will get for the lowest level of price.
Okay.
You have to pay more to get a proper SLA. This $17.50, don't assume that they're going to do whatever you want. And any high level SLA you want, you can get. Not for this price. No, not at all. Not at all. In fact, what they will do is Compose will look at MongoHQ.com.
So I think that he's asking,
how do they come up with this, basically?
Or also, is there an you were asking about like IOPS, right, or processing power? What exactly? Yeah. So is the lowest micro one? Usually, what they do is they say this little on Amazon anyway. This little tiny database includes this many IOPS, this much CPU, this much memory, and it's a little standard size.
Correct.
And if you go above that, you either fail or you burst, and they charge you for it.
That's right. That's exactly how it goes. In terms of baseline, they'll give you basic minimum, and from your perspective, you need to understand what you want or what you rather need for your application, and then you decide how much can you spend for a reasonable amount to make sure that most of your application requirements are actually met from your customer perspective. They will give you a standard offering, and this is what we got, but that is irrelevant to you. For you, what is relevant is what your customers want. And then you have to actually calculate what IOPS you need. And there is Conrad's response to elastic deployments. Let's go read that. Okay. So here is the how am I build. 60 disk IOPS is what they are suggesting that we provide. And you can read more on the link that Conrad just gave out.
And if you go look at the sizes on the like the 2XL size on Amazon, that is a bundle. It's a standard bundle of CPU, memory, disk, and IOPS usually.
Yeah.
And then after that, it's like whatever you want to pay for, they will give you. So it's very, very cheap when you start out, but it can get very, very expensive quickly depending on what you do.
Right. And that is why it is important to understand and be reasonable about what you really ask for from an SLA perspective. Don't ask for an arm and a leg, because they will charge you an arm and a leg and give it to you. So be reasonable in terms of what your customers really want. And actually do some proof of concept. Do our customers really want that SLA, or are you just dreaming something up? Sometimes customers demand, but they may not realize what they're demanding because it might come with a cost. And that costing is critically important when most SLA discussions boil down to, okay, how much money you have, and I'll give it you. I'll do whatever you want. I'll dance every night for you, making sure that these machines are up and running, and all the IOPS are performing just like you want, but then it costs money. So it may not become affordable. So you have to take a step back, look at your customer, see what they want, see what you can get away with, and then translate that to what SLA you will actually insist or demand from your provider. And then you do that math and then tell them, you know what, this is what we really, really need to have. And sometimes we want more. And for that sometime, will give you give it extra budget or a burst, and for that you charge us, but then we need that bursting capability at certain times, and that has to be understood upfront. If that is not clear, get ready to get screwed royally, because they will do it if you don't agree upfront.
Also, I have a follow-up question, Nilesh. Like you talked about the database service, right?
Yes.
So can you talk a little more maybe in the next class, like what goes behind that? Like what are the ways to scale in terms of like sharding, or whether they do horizontal or vertical sharding, or are there other methodologies they leverage?
Yes.
Because I think what you kind of talked was like a facade. Okay, there is a service which provides that, but let's say you want to do it yourself, then what are the ways to scale?
Yeah.
One more question along the same lines, Nilesh.
Yes,
if you can talk about what are the common types of applications that are well suited for the cloud, and how would you, what changes would you have to make for a typical application to take it to the cloud?
Okay, so the question you had is what changes you make to a typical application. To answer that question, I would like to understand, what do you have in mind for a typical application? That's something that I need to understand, because people. So give me examples in Slack chat. Give me examples of applications that you think you have in mind that you think are typical, and then I can then precisely answer to you how or what, if any, needs to change.
I think if I understood correctly, I think he's looking to you for your opinion on. Sir, whoever asked the question, is that the case where you're looking for Nilesh's opinion on what he sees as use cases for the cloud? Was that the question?
Right.
And then the actual changes from the physical world to the cloud world that would have to transpire. So like a matrix of like, for this case here, you'd use this. For e-commerce, you'd use that. Or this would be good for the cloud, or email first, or less production critical, or whatever have you.
So what I would suggest is that go to Bootcamp and then click on the Cloud Technologies button here, this one. Click on this one. And on that page, search for this word. I'm going to type it for you. It's called 12-factor. 12-factor. This is what you want to read about a classic example of an application that is the best suited for cloud deployments. What characteristics are needed for applications to be better citizens in the context of cloud? There are 12 factors that are defined here in this 12-factor app discussion. Right there.
Perfect. Yep. Thanks.
That is what you should read. It is in the module, in the listing. Scroll down, you will find it.
Doesn't it really just depend on which kind of cloud service you're utilizing? Because if it's a SaaS app, you're obviously, if you're just using platform as a service versus infrastructure as a service, I mean, couldn't you actually run anything? Because if you have the infrastructure to do it, I don't see how you could be limited by what kind of application you could run.
So yes, you're right in that the idea is to be able to understand what are you dealing with. But then the question that we were discussing is in terms of what application characteristics are needed for a successful deployment in the cloud. And also for a given application, what do we need to change for it to become better suited for a cloud deployment environment? And that
I see.
Right, that gets answered in the context of what characteristics and factors are needed to make it easy for somebody to, or some application to get adopted for deployment in the cloud scenario. And that's the discussion we will have at 12-Factor App Manifesto. So go read that and we'll discuss more about it.
I see. Yeah, that could be something like portability, I guess.
Yeah, there are
One of
lots
the
of
reasons
things.
why.
Yeah, there are 12 factors, in fact, defined here.
All right, I'll check that one out.
Yeah.
So are there exercises that we should do?
For right now, the exercise for you is to create accounts with Amazon. That's one simple thing you should do. And we will begin some basic steps to be able to understand. We will go over examples of infrastructure as a service to begin with, for which I would like you to be set up with the Cloud Genius workstation. We'll also do some security discussions in terms of understanding security as in private key and public key pairs, understanding authentication, understanding some related aspects regarding authenticity of an object or an item that you download from the internet. We'll cover these aspects before we jump into connecting to a cloud provider. We'll experiment with infrastructure as a service first. Then we switch over to a little bit discussion on software as a service because it is trivially simple. And then switch over to platform as a service and go detail about using Heroku. And then there is a new segment here in the Hub, as you can see in the write-ups. We will set up our own platform as a service. And that is also in the in the listing here, as you can see in the reference material. We'll also go over. Go ahead.
Well, hang on a second. So our assignment is to set up Amazon accounts and set up.
That's it.
The Cloud Genius workstation.
Okay. Set up Cloud Genius workstation and use a credit card to set up a free account with Amazon. That is the free tier option that you have. That's it.
Okay.
Cool. By the way, Conrad, if you can please join on Slack chat and post these links in the Slack chat, that will be much better. They get preserved in the chat. In this GoToMeeting chat is lost. The links get lost. I cannot preserve them. So Conrad is suggesting this book, which is a good one. And that is something you should read. But I'm going to paste this link in Slack chat, which is...
I already did. I just did.
Thank you.
So.
Thank you.
Sure. I will cut and paste.
Yeah, another one that Conrad just posted, also a very good book. And so these things are tremendously useful. If you preserve them in Slack chat, that helps everybody. Cool. Conrad, please join the Slack chat discussion. You can click this and invite yourself to join. http://chat.cloudgenie.us. So click here and invite yourself, and then you can participate in the group chat discussions. Cool. So thank you very much. We'll see you again Thursday at 6 o'clock Pacific time, same method.
Excellent. Thank you.
You're welcome.
Thanks very much.
Thank you.
Thanks so much.
Thank you.
Bye.
Thank you, everybody.
Thanks.